convergence of sequences, real sequences and real series. We take off from there. Okay, so what is this whole uniform convergence about? So first of all, I will remind you, हम लोग जो since the Africans are not here, I can break into Hindi and I feel more comfortable. When we were looking at sequences, many times in the sequence that we considered, there was an X in the picture and the answer depended on X. That if X is, for example, so this is just the introduction. While studying the behavior of real sequences and series, there was often an X in the picture. And the answer depended on the value of X. What is it, Kuka? You couldn't hear anything?
No, I'm fine. I think Lucky said something.
Okay, Lucky said.
Yes,
what happened, Lucky?
Small question, ma'am. We'll get the recording of these lectures as well, right?
Yes, these are being recorded.
Okay.
So while studying the behavior of real sequences and series, there was often an X in the picture and the answer depended on the value of X. For example, we had some sequences like X to the power N. Okay, so we had to find out for which values of X it converges. We had, when modulus of X is less than 1, it converges to 0. When X is equal to 1, it converges to 1. When X is equal to -1, it does not converge. If mod X is greater than 1, it doesn't converge. If X is greater than 1, diverges. Everything depended on X as well. So the sequence itself was like this. N goes from 1 to infinity, but the answer depended on X. Or you may have something like this. This was also when we used the consecutive ratio test for sequences to prove that this sequence converges for all values of X. It doesn't matter what X is. Okay, so we had many such sequences. We also had series of this kind, 1 plus x squared by factorial 2, like this, which converges to the exponential of x for all values of x. But you also had these other series, sigma xn. Yeah, okay. So we had this x minus x squared by 2 plus x cubed by 3 minus so on. Among some of the last problems we did, you might remember, Abhinav, that this series converges for mod x less than 1 and for x equal to 1. So this was convergent for 1 minus 1 less than x less than or equal to 1. So we call this interval minus 1, 1 the interval of convergence. Outside that interval minus 1, 1, it was divergent. Okay, this was one of the last few series we had done. There's a bit of a gap between when you finished KUKA. So we had used we tried to find where it is absolutely convergent by using the Allenbert's ratio test. We removed all the minus signs and replaced x by mod x. And then we found that the series converges for mod x less than 1, absolutely. Then at x equal to 1 and minus 1, we checked it out. We found that it converged for 1 by the Leibniz's test of alternating series, but it didn't converge at all for x equal to minus 1. Okay, because then all signs become minus. So it becomes sigma minus 1 by n, which is divergent. So, the answer, you don't have to remember exactly when they converge. We're going to do it again. But the answer depended on x as well as n. So these could be written as, say, fnx, right? N going from 1 to infinity. So it was a function of both n and x. And these could be written as sigma of the same thing, fnx. N going from 1 to infinity, and it depended on x as well.
So we are talking about series or sequence?
Both. I mean, right now, and as an introduction, I'm talking about both. So the series also are basically sequences in the sense that the behavior of this depends on the behavior of the sequence of partial sums. So eventually, we are talking about sequences which depend on both n and x. Okay. So now, what we are going to do in this chapter now in this course, okay, is the following. You see, so each of these is a function of x. Fnx is a function of x. So I, instead of calling it Fnx, which is a real number, I'm going to call this function just Fn. That's the usual notation for function. Fnx is the value of the function Fn at x. लेकिन function क्या है? Fn है. Fn. So we are going to talk about sequences of functions and series of functions. So in this course,
वो आपने क्या लिखा है?
कहाँ पे? ऊपर
-1 से x से 1 तक
convergent है, convergent. It is absolutely convergent. Okay, so it's convergent absolutely for -1 less than x less than 1 and convergent for x equal to, conditionally convergent, CC for x equal to 1 by Leibniz's test. 1 minus half plus 1/3 minus 1/4. अभी किया हम लोगों ने. So, but it is not convergent anywhere else. At x equal to -1, divergent. For mod x greater than 1 by NCC, we showed that it is not convergent. So this is your, you've come across the whole idea of a sequence or a series depending on the nth term, depending not only on n but also on x. Okay, so I'm taking off from there and saying that let us.
C for x is equal to 1.
Pardon?
CC for x is equal to 1 क्या है?
CC, conditionally convergent for x equal to 1.
Okay.
We've just done it a little while ago. Okay, the specific answer is not important. The main thing is that you have come across such series where there was an x also in the picture and the answer depended on x. All right.
So we are generalizing more. We are removing the x from the picture and using functions instead.
Yes, yes. So this prompts us to study what we call sequences of functions. Okay, this motivates us to study sequences and series of functions, of real valued functions. They're all real valued functions defined either on the whole of R or on a subset of R. Subset of R. Say Fn. So when you say it's a sequence of functions, you don't write the value at x down. Fn is a function defined on its domain. The domain may be the whole of R or the domain may be a subset of R. Okay? So we just take the function part of it. We don't take the image of the function at x. The image of x under that function. नहीं, वो नहीं ले रहे हम function को ही ले रहे हैं. So there's a difference between saying fx and f. F is the function and fx is the image of x under the function. Okay, so correctly speaking, the function is just f. Fine. And similarly,
So
concept of the series of functions. Okay, once we study this, then after that we'll study this in terms of this. All right. Yeah, Abhinav, you have a question?
When real valued function means the domain of the function is real.
No, real valued means the codomain is real.
Range.
Range, yeah. The range is a subset of R. Real valued. Value is always the codomain or the range. Like if you say fx, x is in the domain, fx is in the codomain. So the value is fx.
Sequences into one of the type of functions on natural numbers.
That's okay. But now we are moving beyond that. You see, sequences of what? You can have sequences of events. You can have sequences of sets. You can have sequences of people. All right. So like that, you have sequences of functions. Each element here is a function. It's a sequence of f1, comma, f2, comma, f3, comma, fn. So Fn is not a real number. Fn is a function from some domain, the common domain, from some domain D, which is a subset of R, into R.
Well,
Okay? So we are going to study in this entire course. The course is also called Sequences and Series of Functions. I mean, some universities call it uniform convergence, the whole paper. Some universities call the paper, and some books call the chapter Sequences and Series of Functions. Okay? So you can have...
Which means, ma'am, each function in that sequence will be a different function.
Yes. It could be the same, but it is in general different. Okay, it's like,
will there be a connection? Will there be a connection between each other? There should be, right?
The domain is the same. The domain is the same, right? So this will be F1, F2, F3. Each of these is a function. Okay, sigma Fn, n going from 1 to infinity is F1 plus F2 plus F3, like that.
Question is, if they
अभी तो सिर्फ introduction है.
have the same domain.
Yeah, they will have the same domain. In one particular sequence of functions, the domain is common. In another, also, the domain is common in that case. All right.
That is how we define the sequence.
Nothing is that formal yet. Abhi to sab introduction hi hai. I'm just preparing you for the formal definition. Abhi a formal definition.
थोड़ा vague लग रहा है.
तो introduction हमेशा थोड़ा सा vague होता है. Right, vague in what sense? Abhi formal आएगा definition, then it won't be vague. So when you say sequences, you're not only talking about sequences of real numbers. Na? Sequence in a set A is a function from n into A. So the set A could be anything. You can have a sequence of blades of grass. Grass, blade 1, blade 2, blade 3, blade 4, blade 5, ... You can have a sequence of people, which is a queue. Okay, like you have, cinema hall ke samne, first person, second person, third person, fourth person. For each natural number that is a place, there is a person attached to it. Okay, so obviously you have not heard even one lecture of mine on sequences. Because I start by saying a sequence in a set capital A. I don't only talk about a sequence from n into R. That is a particular case which we studied in first semester. I talk about a sequence of events. Okay, it's like a set of events put in a particular order. तो सीक्वेंस तो किसी भी चीज का बनाया जा सकता है. बस कंचे ले लो, उनका सीक्वेंस में लगा दो. एक चींटियां ले लो, उनको एक सीक्वेंस में बना दो रो. Right. All I'm saying is that each object, that is the element of the sequence, is a function. That's all. Function 1, function 2, function 3, function 4. उसमें क्या वेग है? Functions are mathematical entities. Okay. So,
there is a domain, like the sequence from.
Don't get into the specifics.
Function from n into A.
No, the
domain is n.
But each function is a real valued function on some subset of R. Don't be in a hurry. We've not even started. I'm just giving you an idea of why we're interested in this. This is called, the whole course is called Sequences and Series of Functions. Okay. So the set A, I mean, in this case, so abhi introduction hi hai. So earlier we had said, for any non-empty set A, we had defined a sequence in A. What is the meaning of a sequence in A? To be a function from capital N into capital A. A could be a set of people, it could be anything. I don't know what it is. Okay. So, and then we have we represented as AN, that is A1, A2, A3, where AN is an element of capital A. It could be a person, it could be a blade of grass, it could be an ant. So if you take a function from the set of natural numbers into the set of ants in the world, then you have first ant, second ant, third ant, and so on. Each an is an ant. फिर हमने वो रियल नंबर्स, ए को रियल नंबर्स लिया था, तो वो रियल सीक्वेंस हो गई थी. But sequence by itself doesn't have to be a real sequence. It can be a sequence of chairs or tables or whatever you want to make. So हमारे लिए sequence infinite sequence होती है. इसका जो domain है वो n है और a. So instead of taking a as just the set of ants or people or anything else, suppose I take it as a set of functions. Okay, in our course that we are going to do now, we take a to be a set of real valued functions on a fixed domain.
F is n and fx is a.
No,
Right.
no, not at all. Okay, please just focus on what I'm saying rather than talk about what I'm not saying. Where's the F here? So you have a function from n into a, which I call an. It's like a mapping. A mapping. There's no F here right now. It's the function is called a mapping n into a, where a of n is written as a subscript n. A of n means the image of n under a. Now I'm taking you back to the first semester, first lecture. I mean, after logic and all was done.
So n is the domain and R is codomain.
R is not the codomain. R was the codomain. Past tense, semester 1 में.
R was the codomain. Now
Capital A was
is the
R.
codomain.
Now A is an unknown set. So you have a sequence
Okay.
of elements of A.
Okay.
The nth term of it is the image of n under the function A, the function from n into R. Every element has to have a unique image, so it's called an, which is also represented by a subscript n. So if you write it like this, then it means the first element here is the image of 1, second one is the image of 2, third one is the image of 3 and so on. Okay? और जैसे क्यू ऑफ पीपल बनेगा तो हमेशा 1 2 3 4 जमीन पे लिखा नहीं होता है. The first person is the image of 1, the second person is the image, the second person is the second in the queue. So the image of 1 is the first person, the image of 2 is the second person and so on. So that's a sequence of people. It's a function from the set of natural numbers into the set of people. Obviously it's not on to, सारे लोगों को थोड़ी डाल रहे हैं, कुछ लोगों को डाल रहे हैं. फर्स्ट प्लेस में कोई आदमी है, सेकंड में कोई और है, थर्ड में कोई और है. Every place has a person attached to it, that's all. A unique person.
So
नहीं तो झगड़ा होगा.
domain is just the indexes. That's what the domain is, right?
Yeah, the indices are the domain set n.
Okay. Okay.
So this is like taking you back to the beginning. Now we have to come forward and come to the present. All right. So in our course, Abhi, current course, we take A not to be the set of real numbers, but real valued functions on a fixed domain S. There can be all kinds of functions. Suppose I take, say, F, which is a set of all functions. Say F, all functions from S into R. सारे फंक्शंस. तो बेसिकली कई बार हम ये एस को एक इंटरवल लेते हैं, बट इट मे नॉट बी एन इंटरवल इन जनरल, बट मोस्टली वी आर यूज्ड टू टेकिंग इट एज एन इंटरवल. तो इसके ऊपर सारे फंक्शंस, कोई भी फंक्शन बना दो, चाहे कंटिन्यूस हो चाहे नहीं हो, हर तरह का फंक्शन, फंक्शन फ्रॉम अ सेट एस इनटू आर. एक्स एक्सिस में सबसेट एस लिखा जाता है और वाई एक्सिस में ये जो इमेज मार्क होती है. फॉर ईच एक्स हियर there is something called fx, right? fx. So that's how you, those are the functions जो आप स्कूल में पढ़ते थे. This is all going to come into analysis too. अब unfortunately वो हम लोग अभी शुरू नहीं कर रहे हैं. आप लोग तो semester 4 का पेपर कर रहे हैं ना. This is a semester 4 paper. or some amount of continuity and all, I'll have to take for granted. But so I've just drawn some functions on this domain, अलग-अलग type के functions. तो ये f जो है, this consists of all functions from S into R. Okay? Now you pick out some of them for this sequence. Okay? So that is your function, your sequence will be, let us call it whatever you want to call it. The sequence is a function from n into fancy f. So हर place के लिए एक इसका element होगा. Say f1, f2, f3 like that. Instead of a1, a2, a3 where these an's are ants, it's f1, f2, f3 where these fi's are or fn's are elements of f. कोई खास फंक्शन हम चुनते हैं, पहला फंक्शन, दूसरा फंक्शन, तीसरा फंक्शन, डॉट डॉट डॉट. So this is a sequence of functions. A sequence itself is a function, so it's like a function of functions from the domain n into the set of functions.
मैम ये समझ में नहीं आया मैम. The sequence is a
Sequence itself is a function, but don't call it function because you'll be confused. Your set A, instead of being ants, are also functions. So let's just say it's a sequence. A sequence of functions is a mapping from n into f.
It itself is a function as well.
Yeah, it's a function, but let's call it a mapping. It's a mapping from n into f, where f is the set of functions from S into R.
Okay.
अब देखो, जो आप सीक्वेंस है ना, ये इसका हर एलिमेंट जो है जिस सेट में होगा वो सीक्वेंस उसी सेट में हो जाएगा. तो इंस्टेड ऑफ टेकिंग एंड्स, चींटियों को लेने के बजाय अगर हम हर एक इसको एक फंक्शन बना देते हैं, उसमें क्या प्रॉब्लम है?
नो मैम वो बात नहीं. मेरा क्वेश्चन ये किस सीक्वेंस का आप बात कर रहे हैं?
इस सीक्वेंस. हमें नहीं मालूम कि f1, f2, f3 क्या है. क्या हमें ये मालूम था a1, a2, a3 क्या है? हमें नहीं मालूम है. हमें किसी भी रियल सीक्वेंस के भी बारे में जब हम बात करते थे, हमें नहीं मालूम था कि वो ans हैं क्या, बट है कुछ. There are so many different kinds of sequences. So these FIs, I don't know what they are, but they are, each of them is a well-defined function from S into R, from a subset of the x-axis into the y-axis. Okay.
So earlier what we did was we defined some or like proved some theorems on real numbers, sequences of fixed real numbers, but now we are doing it for arbitrary functions instead of fixed real numbers. But
those were not functions at all. Those were just real numbers. All right. It was a sequence of real numbers. This capital A can be anything. I can be birds in the sky. All right. It doesn't matter what it is. But we did it only for capital A being R. Now we are doing it for capital A being F.
Which we will define later accordingly.
Yeah, the S will change, but otherwise the rest is the same. Depending on what S is, this family F will change. Okay. They have to be real valued functions, and then if for one family F, this S is fixed, right? S is fixed for some subset S of R here. And obviously it has to be non-empty. So the S is fixed here. We can just call it S here if you want, because S is fixed in this discussion. आप S को बदल दोगे तो ये पूरा बदल जाएगा. डोमेन सेम होना है.
तो लंबी लाइन का क्या मतलब होता है? F के बीच में जो लंबी लाइन है.
Such that. Since I'm using dot dot for function, then I use lambi line for such that.
Okay.
F such that F is a function from S into R.
Okay. Cool.
Now let's come to the formal definitions. Fine. Okay. So I've just told you what this course is about. We are going to study the behavior of sequences of functions definition. Let Fn be a sequence of real valued functions on a fixed, on a non-empty, let me call it fixed, non-empty subset S of R. Let me just give you examples of two functions of this kind, and then we'll go on to see what is it that we want to prove about these functions. For example, I'll take two very simple ones. आगे हम और complicated वाले करेंगे. So in the first half of my course, I will only talk about sequences. It's only after we've thoroughly discussed them that we'll talk about series of functions. जैसे हमने real numbers के लिए भी किया था, ठीक है? तो अभी सिर्फ हम sequence की बात कर रहे हैं. E.g., अभी तो definition पूरा नहीं हुआ. I've just said let it be a sequence of functions. For example, consider Fn where for each n, Fn maps R to R. So here I am taking S equal to R as Fnx is x by n for all x belonging to R. अभी हमने डेफिनेशन में कुछ आगे बोलना भी है, लेकिन अभी तो मैं सिर्फ समझा रही हूँ कि इस दो एग्जाम्पल्स के थ्रू कि ये लगता कैसा है. सो for each n, Fn is a function mapping R to R given by this formula. Fn of any x is x by n. This is defined for all real x's. So the domain is the whole of R. Now let's just draw this sequence of functions. Okay. So if I take, for example, the first one, Fnx equal to so this is the x-axis and the y-axis. The whole of the x-axis is the domain and y-axis is the codomain. So suppose you want to draw F1, for example. What does F1 look like? You put n equal to 1?
Straight.
Yeah.
Straight line.
Which straight line? F1x is, slope is 1. Slope is 1. F1x is equal to just x. So let's just draw that first, F1. The first member of the sequence is drawn like this. Okay? Now.
Slope 1. Why is slope 1?
Why is the slope 1? Because the line y equal to x has slope 1. Y is equal. There's no c here. C is 0. M is 1. Y is equal to x. Fnx is like your y. Now y is equal to Fnx, which is x by 1. So the function here, F1x is simply the function x. So the function x, basically, the y equal to fx, if you think of it like that, is the straight line with slope 1. Okay, m is equal to 1. Right? Okay. Then you have, if you take Fnx, if you take x, n equal to 2, then what does your F2 look like?
N equal to
X by 2. X by 2. You have to replace n by 2, na? So this becomes F2x is x by 2 for all x and r. So what is that line? Y equal to x by 2. So इसका आधा हो जाएगा ना यहाँ पे यूँ. It will be halfway down. That is the earlier y का आधा हो जाएगा अब ये height. ठीक है? So you just join this. This is F2. And similarly, F3 is x by 3. So it will be 1/3 of this difference. So it will be like something like this.
converging to 0.
Well, that's what we think. So it's going down like that. So if you, after some time, it will be so close to the horizontal that you can't make out the difference. Although it will never be equal to the horizontal because whatever n may be, this is not 0. It's only 0 at this point. Okay? But it looks like it's tending to 0. How do you define this tending to? How do you find out the limit function? The limit function of this looks like it is 0. But how to define it? And what more do we want to say about it? वो हम देखेंगे. अभी तो मैं सिर्फ ये function डिस्क्राइब कर रही हूँ. इस तरह से आ रहा है, ये नीचे होता जा रहा है, फाइनली वो लेवल हो जाएगा. ठीक है, समझ गए? तो इसके अल्टीमेट बिहेवियर में हम इंटरेस्टेड होंगे. इस सीक्वेंस ऑफ फंक्शंस के अल्टीमेट बिहेवियर में हम इंटरेस्टेड होंगे. फाइन. Okay, so one more example. May I clean this and I can just write it here itself? Don't
Yes.
worry, I'll draw as many diagrams as are required. Because इसमें visual बहुत important रहता है हमारे लिए. Real numbers, मतलब analysis में visual is very, very important. So, number 2. I want to define it. Fnx. Fn maps R to R again as Fn of x
Something, but I don't know if it's right.
x to the power n for all x belonging to R. Yes, what is it that you wanted to say?
And I've noticed something, but I don't know if it's the right thing that I noticed.
No, notice it and tell me what it is.
Ma'am, in real analysis, what we did was we were stuck with, like mostly we were dealing only with one dimension, like in one.
No, we were drawing it like that. We didn't have to draw it like that, but we said कि n तो fixed है, so we were doing it like a shooting star, on this straight line only, flashing green lights.
Yeah, but since it's a function, then mostly तो हम two.
It's not a function. No, these are functions from R to R. So the graph is drawn in 2 dimensions. वही ये दूसरे कैलकुलस वाला पेपर जो तुम करने जा रहे हो 11 फरवरी से, उसमें हम इसी तरह के फंक्शंस की बाल की खाल निकालने जा रहे हैं. लेकिन अब आई हैव टू टेक इट फॉर ग्रांटेड बिकॉज यू आर इन सेमेस्टर 4 राइट नाउ. भी सेमेस्टर 2 का पेपर बचा है, 11 फरवरी को होगा शुरू. तो दैट नीड्स दिस. But since Kuka of course has done it before, so it makes sense. Abhinav wanted to do it, and you will be in a position to do it. No problem.
Well, I just opted in because I thought that it's just a continuation of what I was doing, but no problem.
No, it is a continuation. It heavily banks 99% on the concept of sequences and series which you've done. And 1% it banks on this whole concept of continuity and all, which you just take for granted. School से करते आ रहे हैं ना, तो थोड़ा बहुत उसका मैं, और by then we hope to catch up. Because you see, हम जब कैलकुलस पेपर शुरू करेंगे, हमें वो दोबारा से पूरा रियल नंबर सिस्टम थोड़ी करना है. जो नए लोग हैं उनको करना है, तभी तो उनको हम 2 हफ्ते का गैप दे रहे हैं, लाइक प्रिंस. तुम्हें करने की जरूरत नहीं हो, तो वो पोर्शन तुम कर चुके हो. तो हम लोग सीधे लॉन्च ऑफ करेंगे 11 फरवरी को लिमिट्स ऑफ फंक्शंस ऑफ रियल ऑन डोमेन्स व्हिच आर सबसेट्स ऑफ आर इंटरवल्स. लिमिट्स ऑफ फंक्शंस ऑन इंटरवल्स, वो कॉन्सेप्ट्स हम स्ट्रेट अवे आएंगे. फिर कंटिन्यूटी बहुत जल्दी आ जाएगा, फिर डिफरेंशिएबिलिटी भी बहुत जल्दी आ जाएगा. तो उसमें समय नहीं लगने वाला है. तो राइट नाउ यू हैव टू जस्ट टेक इट फॉर ग्रांटेड बिकॉज आई कांट पोस्टपोन एवरीथिंग. फिर तो हम कॉस ही नहीं पूरा कर पाएंगे. तो मैंने सोचा था कि यूनिफॉर्म कन्वर्जेंस तो शुरू कर देते हैं हम लोग. ठीक है, ओके. सो हाँ, तो सर्टेनली, आई मीन जैसे रीमान इंटीग्रेशन पूरा किया, यू नीडेड कंटिन्यूटी देयर, बट वो पूरा मैंने रिवाइज करके फिर कुका के क्लास को कराया था. But here we don't need to because I am going to revise it, so there's no point my wasting time going over all of that. वो बीच बीच में मैं बताती रहूंगी. Right, now fnx is equal to x to the power n. For this, draw this. इसमें visual, as I said, is very important. So each of these is a well-defined function क्योंकि polynomials पूरे R पे define होते हैं. This is also a particular case of a polynomial of degree n, है ना? So let us draw it. And then you are already noticing their behavior, ultimate behavior, है ना? तो ये 0 है. तो पहला वाला फंक्शन कैसे लग रहा है? Same as before.
Yes, ma'am. Same as
Okay. So this is f1. Now what does f2 look like?
Parabola.
Parabola. So suppose this is the point 1, 1, 0, minus 1, 0, right? And then this is the point 1, 1. इसी के ऊपर. So your parabola will go when x is equal to 1, y is also equal to 1, x squared,
Yes.
like that. Okay, I mean it should be a little more accurate, but doesn't matter. कोई हम tracing of curves नहीं कर रहे हैं. So this is f2. Okay, f2 is totally above the x-axis because it is positive, non-negative, 0 here only. Fine, this is f2. What does f3 look like?
Ma'am, I have no idea.
Ma'am, it will be
There-
this, then this. It will.
It's flatter. It's a flatter curve. It's flatter than this. Goes up like that, and there'll be a point of inflection here, and it will meet this point here when x is equal to -1. Y, which is x cubed, is equal to -1 also. When x is equal to -1, when x is negative, y is also negative. Okay, so this
What is
function,
this shape called?
nothing. So this is f3. So it's going to become flatter here and sharper here. Fine. For every even n, it's going to be an even function which is going to be totally above the x-axis, like this. Flatter here and then going up like this. I mean, it may not be 100% accurate, but I mean, little bit you can try and draw as accurately as possible, like that. Flatter. So you'll find that this is getting flatter and flatter and flatter. और यहाँ पे क्या हो रहा है? हर जो odd function है वो यहाँ आ रहा है, और जो even function है वो ऊपर जा रहा है. ठीक है, तो अगर हम देखते हैं कि इवेंचुअली क्या बिहेवियर इसका होगा जब ये फ्लैट 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 होता चला जाएगा, या ये तो सारे 1 पे आएंगे. दिस इज द पॉइंट 1 1. This is the point 1, 1. Y is equal to 1, x is equal to 1, y is equal to 1. This is the point -1, -1. This is the point 0, 0. तो सारे के सारे इसमें पास करेंगे, तो even the ultimate value will remain here, the eventual limiting value जिसको कहते हैं, और बाकी सब फ्लैट होता जाएगा, बिल्कुल फ्लैट हो जाएगा. You will see it will be indistinguishable from this line. It will become 0. यहाँ भी फ्लैट होता जाएगा, तो यहाँ भी 0 हो जाएगा, बट -1 पे ऊपर नीचे जा रहा है. Okay, so we feel that its limiting function will be 0 from here to here, ये 0 from here to here, and suddenly it will be 1 here. That we will verify, but it looks like that, na? Ultimate value.
That from the previous result also. It is,
Yeah, exactly. So that's one way we were thinking of how to define the convergence of this sequence of functions. So now we are going to come to the actual definition. अभी तो सिर्फ example हो गया, अभी definition हुआ ही नहीं है. So the meaning of convergence of a sequence of functions, I'm coming to that. Okay. So the way in which we'll define it.
What is the limiting function?
I'll just tell now, we haven't written it down. Okay, we are going to define what it is. So basically what we want to see is that if you take any x in the domain, any fixed x in the domain, it may be any real number, then each of these is a real number. Now this f1x ये है, फिर f2x ये है, फिर f3x ये है, फिर f4x ये है, नीचे 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 जा रहा है, finally its limit is going to be 0. And अगर ये x है, x equal to 1, तो वो नीचे नहीं जा रहा है, वो वहीं रह रहा है. अब यहाँ पे अगर x है तो हम देखेंगे कि ये इसका जो f1x f2x चाहे आगे पीछे जा रहे हैं, है ना, ऊपर नीचे जाएंगे, but they're still also coming eventually close to 0. Okay, when x is negative but it is still greater than -1, then we'll see that this is going to be tending to 0, and then at -1 you will find that there is no convergence at all. Okay, so we are going to decide first of all कि अगर हम x को fix कर देते हैं तब fn(x) becomes a sequence of real numbers. If that converges, then the set of all the limits, we are going to say that is the limiting function or the pointwise limit. Let me write it for you. Okay, so the idea of the meaning of convergence of the sequence of functions, this is called pointwise convergence, because what we do is we fix an x and take the limit point by point. हर x के लिए एक sequence of real numbers खड़ा हो जाता है, ये dot 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 जो मैंने बनाया है. तो as n tends to infinity, what does fn(x) tend to? That is a problem from sequences. We can find out the answer. Okay, and those x's for which it converges, they will then constitute the domain of the limiting function. Okay, so the sequence of functions, whether it converges to a limiting function, for what x's does it converge, we have to see. I'm cleaning this to write now the definition. Definition motivated by these examples. So this is a straightforward definition which we call the pointwise definition. Okay, अभी तो ये definition हम पूरा कर ले. Okay, if okay, let f be
Nandita, the upper part is also part of the definition, the part you've written before.
only this is part of the definition, then we broke into examples. Okay. Okay. For each x belonging to S, let the sequence of real numbers वो तो डॉट 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 मैंने ब्लैक वाले लिखे थे ना fn x converge to say, अगर उसका लिमिट है द लिमिट विल डिपेंड ऑन x. जैसे हम लोग करते थे ना, अगर सीक्वेंसेस जो हम लोगों ने किए थे which depended on x, then the answer also depended on the value of x. So if we call the limit fx, let the sequence of real numbers fn x converge to say fx, then we say that the function f mapping S to R is the pointwise limit of the sequence Fn on the set S. Pointwise limit of Fn on S. Or that Fn converges pointwise to F on S. Okay, converges pointwise. Pointwise limit F है, the function F is the pointwise limit, or we say Fn converges pointwise to F on S, and we write this as Fn arrow F on S. I just use the normal arrow symbol for pointwise convergence. Suppose you find that f and x doesn't converge for every single x in S, but for some subset of it, say S1, then we will say that Fn converges pointwise to F on S1. Whatever the region of convergence is, that will be the the set on which it converges pointwise. So this is just a straightforward definition. It depends only on the meaning of convergence of a sequence, as we have done earlier, of ordinary real numbers. Okay. Now let us test this out on the two examples that we did. Okay, now may I clean this definition?
Yes.
Okay, so the meaning of pointwise convergence of a sequence of functions we have. Now let's test it on the two examples I have written down for you.
मैम एक मिनट में लास्ट वाला मत बताइए.
हाँ ठीक है. Test for pointwise convergence the following sequences of functions. The following.
ये समझ में नहीं आई definition.
But FN
Definition नहीं समझ आया?
FN सेम होता है क्या?
हाँ?
FNX और FN सेम होता है?
नहीं, fnx is the value of fn at x. It's the image. Suppose you have a function from the set of men into the set of women. It's a rule. But if I say f of a man, that's a particular woman.
That I understood, but why have you written real numbers FNX on the first part of the definition और उसके बाद आपने FN use करा?
Because we are talking about the meaning of the sequence of functions converging, not a set of sequence of real numbers fnx. ये fn तो पूरा function होगा ना, जैसे हमने अभी draw किया था. You have all these different functions, है ना? These are fn's. If you fix your x, then this sequence is a sequence of real numbers, which you measure on the y-axis, है ना? I mean, suppose this is f1, this is f2, this is f3, then this is f1x. x है, उसकी value ये f1x y-axis पे measure होती है, इसकी height, फिर f2x, इसकी height जो है ये यहाँ measure होगी f2x. Okay, फिर ये इसकी ये f3 है, f3x is this height which is measured on the y-axis, f3x. This is a sequence of real numbers. And you test it like you test a sequence of real numbers.
Okay, so if range converges, then we say that.
What is the meaning of range converges? Range converges का कोई मतलब नहीं है.
FNX converges.
That is not called the range. That is a real number. It's a real value.
FNX, real value. Fx is the range of Fn.
I'm not talking about all the x's. I've fixed the x. हर एक अलग अलग x के लिए this dot 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 dot. बाकी को भूल जाओ. तो range का कोई मतलब ही नहीं है. ये dot 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 this is a sequence. A1 is f1x, A2 is f2x, A3 is f3x. It's a sequence an. आपने sequences एक साल भर 6 महीने पढ़े हैं. So that's just you test it like you test an ordinary sequence, keeping x fixed. Then x becomes a constant.
So this line is arbitrary. हम कहीं पे भी ये line fix कर सकते हैं.
हाँ, अब x के ऊपर डिपेंड करेगा. x को बदल दोगे तो लाइन बदल जाएगी. हम हर x के लिए टेस्ट करेंगे ना. अगर हर x के लिए ये जो सीक्वेंस बनता है ये कन्वर्जेंट है, तब हम कहते हैं कि पूरे डोमेन पे पॉइंट वाइज कन्वर्जेंट है. पॉइंट बाय पॉइंट कन्वर्जेंट है. हर x के लिए कन्वर्जेंट है.
हर x के लिए अगर एक लिमिट एग्जिस्ट करे तो हम कहेंगे.
हाँ, ठीक है. अब इसको टेस्ट कर लेना हम लोग. टेस्ट करने के बाद ज्यादा समझ आएगा. अभिनव, तुम्हें क्या समझ नहीं आया?
हर x के लिए टेस्ट करना.
देखो, तुम अगर अभी से डर जाओगे तो कुछ नहीं हो सकता. टीडीएस क्यों होगा?
इतने सारे फंक्शन होंगे.
अरे बाबा, लेकिन हमने सारे जितने सीक्वेंसेस किए थे जो एक्स वाले थे, तो हमने हर एक्स के लिए नहीं टेस्ट किया. कितना टीडीएस था? बिल्कुल टीडीएस नहीं था. आपके पास इतने सारे टेस्ट अवेलेबल थे, आपने किया था. आपने सीरीज भी की थी, हर एक्स के लिए किया था. एक्सपोनेंशियल एक्स हर एक्स के लिए किया था. क्या वो टीडीएस था? ये टीडीएस कहां से आ जाएगा? Nothing in our papers is going to be tedious because we have zero calculation. Okay, so it's all abstract. So the question of tedium doesn't arise. Okay, so let's test the sequences. पहले तुम देखो तो फिर तय करो कि tedious है कि नहीं tedious है. So Fn, where Fnx is given by x by n for all n belonging to n and x belonging to r. So this is a sequence of functions fn whose value at x is given by x by n. ठीक है, ऐसे लिखा जाता है. It's a function of both n and x. And we've drawn it earlier. Let's draw it again. फिर से मैं ड्रॉ कर रही हूं. मैं ब्लैक में ड्रॉ करूंगी. First let's draw f1. Okay, that's f1. And then we have f2, which is half of this height. So that's f2. Okay, and then f3. and so on. It keeps going down like that. Okay, now let's fix any x. I'm fixing an x with red. Any x. Okay, so for each x, so how do you test for pointwise convergence? Fix your x. For each x belonging to R, what is the limit as n tends to infinity of fnx? You're going to treat x as a constant and you're going to tend n to infinity. This is the limit of the sequence x by n, where x is a constant. Now, how tedious is this for you, Lucky? Do you know what the limit of the sequence is?
One by n.
X by n. X is fixed.
X is fixed, then it is 0.
हाँ तो फिर क्या प्रॉब्लम हो गया? tedious है क्या? X is like your k ना, so it will be x into the limit of 1 by n which is 0. मुश्किल क्या भी ये जो पूरे सेमेस्टर मेहनत कराई है उसके बाद कुछ टीडियस नहीं होने वाला है. वो तो हो गया, जो मुश्किल थी वो सब तभी हो गई. अब वो आगे चल के मुश्किल नहीं होगी कंसेप्चुअली कम से कम. ठीक है, हाँ अभिनव.
मैम वो जो डेफिनेशन में लिखा था, I was little bit not clear.
हाँ.
वो जो आपने लिखा था ना कि function is the pointwise limit of on that.
Yeah, we call f. It's a name that we give, Abhinav. It's called the pointwise limit of the sequence of functions fn. F is called the pointwise limit of fn. If for each x, वो f कहाँ से आता है? Pointwise हम लोगों ने लिमिट निकाला ना, point by point निकाला है. So it's a name that we've given. It's a logical name. For each x belonging to the domain, the sequence fnx converges to something which we call fx. So fx is the limit of fnx. So we say f is the pointwise limit of fn. Okay, the meaning of that is that for each fixed x, limit of fnx as n tends to infinity is fx. तो यहाँ पे हम fx हम निकालने की कोशिश कर रहे हैं, तो हमें मिल गया 0, which I can call fx. I define this as fx. Okay, so it will be equal to fx say. That means कि f को हम define कर रहे हैं to be 0 for each x, and therefore fn tends to f pointwise on the whole of R, because it didn't matter what x is, है ना. तो बेसिकली ये हमारी हाइट जो इज टेंडिंग टू 0, अगर हम इसको हाइट को मेजर करते हैं तो द फर्स्ट वैल्यू इज लाइक दिस, है ना, एट x, दैट इज फॉर एनी x द फर्स्ट वैल्यू इज x and then the next value is this one, x by 2, then the next value is x by 3. So this is like the sequence x by n. X is fixed, so the sequence x by n we know converges to 0. इसका लिमिट यहाँ 0 आ जाएगा. ये इट्स लाइक हम जो रियल लाइन पे देखते थे ना, वो उसको हमने वर्टिकली खड़ा कर दिया है, उस पे हो रहा है ये 0 की तरफ जा रहा है. पिछली वाले सेमेस्टर की रियल लाइन थी वो हमने वर्टिकली खड़ी कर दी. So fn is said to tend to f pointwise on R, where what is f? fx is the 0 function. So the pointwise limit of this is the 0 function. That is, I'm drawing the limit function in red. So this is the limit function, f.
This is the limit function.
In this case. Okay, let's do one more.
The limit function is whole of...
Limit function is the 0 function on the whole of R. The domain of the real function is the whole of R. Because this convergence happens on the whole of R.
Domain is whole of R, range is 0.
Range is 0. ठीक है, the limit function is 0, its range is obviously 0, singleton 0. अब don't keep saying range and domain and we're going back then to kindergarten. The function is the 0 function. Okay, the limit function is the 0. The pointwise limit is the 0 function. Okay.
Yes.
So understood. इसका हमने pointwise limit निकाल लिया.
तो एक बारी
हाँ नहीं, नोट कर लो. गौतम तुम
My apologies every time.
तुम्हारी recording के बाद ही जाओगे ना, हाँ देर हो जाएगी, इसको जरा गर्म कर दो. हाँ sorry.
Ma'am, every time you say the word function, the only thing that comes in my mind is domain range one.
अरे बाबा अब तो सारी चीज फंक्शन, तुमने पूरा dy by dx वगैरह नहीं किया था, वो सारे फंक्शन ही तो थे. स्कूल में जितना कुछ कर रहे थे, यू वर नॉट डूइंग सीक्वेंसेस एंड सीरीज, यू वर डूइंग लिमिट्स ऑफ फंक्शंस, dy by dx, फिर उसके बारे में कितनी कितनी चीजें तुम लोगों ने की हैं. सारे फंक्शन और इंटरवल्स होते थे वहां पे.
Yes.
du plus v by dx, du v by dx, du by d of u by v, वो सारे कुछ क्या कर रहे थे? साइन एक्स का डेरिवेटिव, कॉस एक्स, वो सारे फंक्शन थे. साइन एक्स फंक्शन नहीं था क्या? कोई नई चीज थोड़ी है.
Yes.
ठीक है, वो तो हमने अब सीक्वेंसेस शुरू किया है कॉलेज में. Okay, so these are all functions. So this is a sequence of functions and the limit function is 0. Now let's look at the next one, number 2. We'll draw it again and then you will tell me what the pointwise limit is. This is also defined on the whole of R, and if you remember what we had drawn, okay, I'll draw it in black now. So this is the point 1, 1, and this is the point minus 1, minus 1. X-axis, Y-axis. Okay, so the first one was basically the same. Sorry, there should be 1, 1, but minus 1 here. Go straight up. Not very accurate, but try to do it more accurately. Right. And then this is 1, 1. Minus 1. Okay, and the next one was the parabola, like that. Okay, this was F1, then F2, then F3 again was coming down to the negative side, so F3 like that. इतना flat नहीं, वो फिर और भी आएंगे. This is a point of inflection. The dy by dx is 0, but it's neither maxima nor minima. Okay, and then so on. So this is F2 and then F3. तो इस तरह से चलता जाएगा, फ्लैटर होता जाएगा. यहाँ पे भी फ्लैटर, दोनों साइड से फ्लैटर होता जाएगा. ऑड वाला नीचे से, इवन वाला ऊपर से, ऐसे होता जाएगा. लेकिन at 1, it will keep oscillating between -1 and 1. ऑड वाले इधर जाएंगे, इवन वाले इधर जाएंगे. Okay, so what do we know about this? Let us write down. For each fixed x, belong to R, what can I say the limit as n tends to infinity of fn x is? This is the limit as n tends to infinity of this geometric sequence x to the power n. And we all know the behavior of the geometric sequence. It is the limit is 0 if mod x is less than 1. The limit is 1 if x is equal to 1, and the limit doesn't exist is does not exist if x is less than equal to -1 or x is greater than 1. If x is greater than 1, it diverges to infinity. I don't have to write all of them separately. If x is less than -1, then it is oscillating infinitely. And if x is equal to -1, then it is oscillating finitely. But वो सारे cases में the limit doesn't exist. चाहे वो oscillatory हो, चाहे वो divergent हो. So this is from our knowledge of sequences. जब x को फिक्स कर देंगे तब तो only n is the variable, तो सीक्वेंस हो जाता है, नॉर्मल सीक्वेंस. अलग अलग एक्सिस के लिए इसका अलग अलग बिहेवियर है, तो ये पूरे के पूरे आर में पॉइंट वाइज लिमिट नहीं होगी. So how do I define the pointwise limit? Define f mapping open -1 closed 1 to R as f of x is equal to 0 for -1 strictly less than x strictly less than 1, and fx is 1 for x equal to 1. then Fn tends to F pointwise, not on the whole of R, but on the interval -1, 1, semi-open. Open on -1, closed on 1. The maximum domain for pointwise convergence is open -1, closed 1. And let me draw the pointwise limit in red. Sorry, -1 पे तो है ही नहीं, है ना, ओपन है यहाँ पे, ये यहाँ, और सडनली ये रेड यहाँ पे डॉट, रेड डॉट here. Okay, if I draw my f here, then it is this function. If I just draw f, this is -1, this is 1. So the function f looks like this. 0 throughout and suddenly 1 here. Open here and 1 here. That is my function. इसका graph जो है ना f का ये है. It's a discontinuous function. It is not continuous at x equal to 1. Just take continuity to mean that you have to lift up your hand while drawing the graph. तो ये function यहाँ तक तो continuous है open -1, 1 में, लेकिन at 1 it is not continuous. So overall it is a discontinuous function. With that remark, I'm going to end our lecture for today, and tomorrow we are going to see why we are unhappy about this discontinuity and what should we do about it. Okay? That's tomorrow. Enough for today.
Thank you.
All right. Okay. All right, Lucky. कुछ पूछना है? अब enough? हो गया?
ये लास्ट वाला पार्ट का एक्सप्लेनेशन थोड़ा
Explanation मतलब ये इसका तुम्हें लिमिट नहीं मालूम है सीक्वेंस का? If x
इसका
ये है ना? If x is equal to 1, it's the constant sequence 1.
या
फिर उसका लिमिट 1 होगा. और अगर mod x less than 1 है तो geometric sequence हो गया with common ratio between -1 and 1. So that is 0. उसका limit. Go back and revise your sequences. I'm presuming that you know all your sequences thoroughly. You pretend to you having a test.
1/2, 1/3, 1/4, 1/5.
क्या मतलब? यहाँ पे कहाँ आ गया 1/3, 1/4, 1/5? This is x to the power n.
हाँ, x to the power 1 by अच्छा x less than 1 है मतलब माइनस.
It is like r to the power n, Lucky, where r was the common ratio of the geometric sequence. If you've forgotten all your sequences, you better go back and revise. तुम्हारा टेस्ट नहीं हुआ, you imagine के टेस्ट हो रहा है. उसके बगैर तुम्हें ये समझ नहीं आएगा.
ओके ओके
ज्योमेट्रिक सीरीज भी क्या है? ज्योमेट्रिक सीक्वेंस भी किया, ज्योमेट्रिक सीरीज भी की, फिर कह रहे हो कि नहीं याद नहीं है. अगर हम r की जगह x कह रहे हैं तो उसका मतलब ये थोड़ी कि वो ज्योमेट्रिक सीक्वेंस नहीं हो के कुछ और हो गया. ये हमने सैंडविच थ्योरम यूज करके प्रूव किया था that the geometric sequence converges to 0 if the common ratio lies between -1 and 1 open.
यस यस आई रिमेंबर दैट. पर
बस-
-1 से 1 में कब लाया करेगा ये?
When mod x is less than 1. अरे x is lying between -1 and 1. This is -1, this is 1. For all the x's between these, the sequence that you get, all right, when you take this dot, 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 that sequence converges to 0. It's like this. You take any one x here, ये कोई x ले लो, ये fix your x,
समझ गया.
ये एक x fix कर लो, तो ये dot, dot draw करो, ये line draw करो. तो what is f1x? f1x is this here. f1x is here. f1x when x is equal to x. Then the next one, f2x, will be the value of this at f2x is the value of this at this point, this one, right? So it will be x squared. Okay, since x is less than 1 here, this x, then x squared, then x cubed नीचे चला जा रहा है. It is a sequence which is measured on the y-axis, it's going towards 0. Okay, और अगर x नेगेटिव है, जैसे यहाँ पे हमने x बनाया, तो पहला x तो यहाँ पे आएगा, यहाँ पे पहला x यहाँ पे आएगा नेगेटिव, ये पहला है, that is x, right? And then the second one is x squared is up here, this one, x squared, And the third one is x cube, which is here, x cubed. So if you draw this line, then it is going back and forth, because it's an alternating sign sequence and x is negative, but it is moving towards 0.
Yes. Absolutely.
The sequence tends to 0. हाँ, ये लाइन बना के देख लो ना, अदरवाइज तो हमारी जो नॉलेज है सीक्वेंसेस की वो हम यूज कर रहे हैं, बट इट्स नाइस टू लुक एट इट ज्योमेट्रिकली आल्सो, द फिगर, you visualize it, then it makes sense. Okay, Abhinav, you have a question?
Ma'am, I have something else to ask.
Okay, sure.
Related to.
Sure.
May I ask?
हाँ, of course.
Ma'am, actually, it is related to this divergent series.
हाँ.
तो उसमें मैम I was came across something that वो डाइवर्जेंट सीरीज को भी कुछ लिमिट असाइन करने का एक मेथड होता है यूजिंग इन कॉम्प्लेक्स एनालिसिस.
अब वो तो no, I don't remember now, because I mean I must have done complex analysis many years ago. I've never taught it.
zeta फंक्शन करके फंक्शन होता है.
हाँ, हो सकता है, but I am not familiar with it.
Okay.
So you better leave it. हाँ, ठीक है. Okay.
Okay, ma'am. I'll drop back to.
Yeah. We are all dropping now. Okay. Thanks a lot. Then
One
I'll see you.
quick question.
Yeah, sure.
Another quick question. So we should brush up on series and sequences from the real analysis.
Yeah.
point
See,
of view.
start with sequences.
Everything.
Yeah. When we start series here, then
Just the
you
results.
brush up on series.
Not the way to prove, just the results.
Yeah, the results, the problems also, like this geometric sequence and all. Statements of results. That basically you need to know
Thank
that.
you.
Otherwise, definitions, when I give, your definitions will come back to you also. I do need the definitions, but they will come back to you. So definitions and statements of results is fine. And as far as continuity is concerned, Kuka, at least you can go back to your Riemann integral notes. शुरू में मैंने 2 classes में I had done a review of continuity and differentiability. You look at that. But the others will have to wait to catch up from the 11th of Feb. Okay? I'll keep telling them whatever I can till then. Okay. All right. Then I'll see you. When is the next class in uniform convergence? Today is what? Today is
28.
Today is Tuesday. So not on Wednesday, I think, but on Thursday we have. No, not on Thursday. बंद कर दो.